how can we minimize the corona? Let's say we have two conducting electrodes in parallel with each other, separated in air by distance d. As we know, air is not perfect, or in simple language, air is not the perfect insulator. Even in the normal condition, air has a lot of free ions and electrons. Now, let's say these electrodes are carrying 25 kilovolts. As these are carrying electricity, each electrode will generate its own electric field, as shown here. Now, the electrons in the air will acquire motion and they start maintaining very small current. This current is almost negligible if the electric field intensity is less than 30 kV per centimeter. This 30 kV per centimeter I'm saying based on the studies made and different calculations. The value depends upon many other factors which we will see in this video. So if the electric field intensity is less than 30 kV per centimeter, then the value of current flowing between these two is negligible and you can ignore it. There is no problem about that. But what will happen if we increase the voltage from 25 kV to 45 kV? Well, of course, you guessed it correctly. Electric field intensity between the electrodes will increase. Let's say it is now 40 kV per centimeter. Now this is enough to break the insulation properties of air. The air will lose its insulation property, complete electrical breakdown occurs and an arc will stuck between these two electrodes. Same thing happens with the transmission lines carrying high and extra high voltage. The only difference is the distance between two conductors is more. When the conductor is carrying high or extra high voltage, air surrounding the conductor becomes ionized due to the electric field around it. Intensity of the electric field is maximum at the surface of conductor, and as we move away from the conductor, it decreases. It is same like magnet and a metal clip. As you bring the clip near to the magnet, you will feel more force. And as you take it away from the magnet, the force will decrease. Here also the same case. Intensity is maximum at the surface, and as you move away from the conductor, it keeps on decreasing. As the intensity at the surface of conductor is maximum, the air near to the surface will become ionized. If the electric intensity is high enough, and because of the breakdown of air, a faint violet glow will appear. And at the same time, humming noise will be heard. And this is nothing but the corona in electrical engineering. If the electric field intensity increases, the glow and the noise will also increase until a spark overtakes place. Further, if the surface of conductor is not smooth and it has some rough points, there the glow will be brighter as compared to the smooth areas. The voltage value at which the breakdown of air happens or the corona starts is called as critical voltage. In our case of two electrodes, critical value was 40 kV per centimeter. The value depends upon many things like temperature, humidity, pollution level in air, condition of the conductor surface, etc. Please remember that corona effect is generally seen in lines carrying 245 kV or higher. So if you are passing by a 11 kV or 36 kV line, you may not see the violet glow and the humming noise will not be there. So this is how the corona happens. Now you may ask, like, corona happens bad in that. Anyways, it is happening at a height, so what wrong it will do? Well, there are few things which corona causes and for which an electrical engineer should be concerned. Those things are power loss over the entire length of line. Because of the corona discharge, power loss takes place over the entire length of line, even in the fair weather conditions. This loss increases when the weather becomes humid. So let's say if the line length is 100 km, and even if we consider power loss of 0.5 kilowatt per kilometer, for our reference and calculation purpose I'm saying, so over entire length we will lose approx 50 kilowatt of power if we consider 0.5 kilowatt loss per kilometer. And if this loss is not controlled, power available at the receiving end will be lower than the sending end. The next is interference with radio and televisions. As we have seen, corona emits a humming noise, and this noise is of a very high frequency which can interact with the nearby radio receivers or TV sets. The next is ozone gas. Yes, corona also produces ozone gas, which can reduce the life of insulator and the conductor. And hence, ignoring corona is not at all a good idea. So, what to do? Of course, we cannot 100% avoid corona, but we can definitely minimize it. Let's see what are the ways to minimize the corona. First of all, what is causing corona? The electric field around the conductors. And hence, to reduce the corona, we should try to reduce the electric field around the conductor surface, either by increasing the diameter of the conductor or arranging the conductors in sets of 2 3 or maybe 4 per phase. This arrangement helps in reducing the electric field around the conductor and hence the corona effect. And this is the reason why you will see bundling of the conductors. Not only transmission lines but also the high and extra high voltage equipment like transformer or circuit breaker, disconnectors, etc. are likely to face the corona effect. In case of such equipment, the corona discharge can happen where there is a sharp edge or the points which has small curvature. This is because electric field intensity is more at such points. This can be avoided by the corona rings. Corona rings are nothing but the ring made up of thick conducting material. Here you can see in the photo it's a circuit breaker and the round thing highlighted is corona ring. What corona ring does is that it reduces the electric field intensity by giving a nice curvature shape at the sharp points. In this way, the current does not ionize the air, but it flows through the round corona ring. Again, this effect is generally seen in equipment which are used above 245 kV voltage levels. So these are the ways by which you can minimize the corona effect. So let's summarize this video. Corona is an effect in which, due to ionization of air, a violet glow and humming noise along with the ozone gas produces. Corona is generally seen in transmission line and equipment of 245 kV and above. Corona can cause a lot of power loss. It produces high frequency noise which can interfere with the nearby radio receivers and TV sets. Ozone gas can reduce the life of insulator and conductor. Corona can be minimized by increasing the diameter of the conductor by bundling sets of 2, 3 or 4 per phase. In case of high and extra high voltage equipment, corona can be reduced by using corona rings. You can take screenshot of this summary slides on your phone, share it with your friends and read it.
Take a screenshot of this. You can take a screenshot of this. ये ले लो screenshot.
Yes, sir.